The Thar Desert in northwestern India and Pakistan is a wasteland of endless, scorched sand. It is hyper-arid. Nothing survives here without a struggle. But hundreds of feet beneath this cracked terracotta earth, hiding in pitch darkness, is a ghost. Welcome to this explainer. We're going to unravel a cinematic mystery spanning from ancient Bronze Age mythology all the way to modern space-age technology. Because today, we're searching for a lost river. Okay, let's dive into this. Literally. Imagine taking a sweeping plunge straight down through that dry desert crust. If you go deep enough, past the dust, past the rocks, you don't just hit dry bedrock. No, you hit a massive, glowing, subterranean river system. It's an underground phantom secretly flowing beneath the dunes for thousands of years. But to really grasp why this hidden water is so revolutionary today, we gotta rewind time and look at one of the oldest texts in human history. So over 3,000 years ago, the ancient Sanskrit text known as the Rig Veda praised a colossal, roaring river called the Saraswati. It was described as this mighty flood, right? A divine force flowing from the mountains all the way down to the ocean. But as centuries passed and the landscape morphed into the arid Thar Desert we know today, the mighty Saraswati vanished from the surface. And for over a century, modern historians and geologists just dismissed the river as pure mythology, an exaggerated legend. But it turns out, we were just looking in the completely wrong place. Now, what's really interesting about this is how we actually found it. To prove this myth was real, scientists at the Indian Space Research Organization, or ISRO, realized they had to look from space. Obviously, you can't see a buried river with the naked eye, so they used optical and microwave sensors on satellites to fire scanning radar down onto the desert. By applying a digital image processing technique, it's called piecewise histogram stretching, they were able to detect these subtle, cool, damp signatures twisting right beneath the dunes. They essentially turned the dull sand translucent. And when that satellite data was processed, the results were absolutely staggering. The imagery lit up a massive, complex, branching network of dark blue paleochannels. These are ancient, dried-up riverbeds right where absolutely nothing but bone-dry sand exists today. We are not talking about a tiny, trickling stream here. This was the digital ghost of a colossal river system permanently carved into the earth. The sheer scale of this discovery is honestly hard to wrap your head around. The radar revealed a continuous paleochannel stretching an incredible 1,500 kilometers in length. Geologists today call it the Ghaggar-Hakra paleochannel system, and this massive scar in the Earth's crust cuts right through modern Punjab, Haryana, and Rajasthan, and extends deep into the Cholistan Desert of Pakistan. But, a dry riverbed is really just half the story. Scientists still needed to know where exactly this river originally came from. So, to find out, geologists drilled deep into these hidden channels. They extracted gray, micaceous sand from about 30 meters below the surface. Then, they used this amazing technique called strontium-neodymium isotope fingerprinting. Here's how it works. The local lower shivalik hills have a very specific low radiogenic signature. But the sand buried in this paleochannel, it possessed highly radiogenic strontium and highly negative neodymium, which sounds incredibly complicated, but it basically acts as a definitive geographical barcode. It proved, beyond a shadow of a doubt, that this sand did not come from the local hills. It was dragged down directly from the glaciated peaks of the higher Himalayas. And it gets crazier. When the Baba Atomic Research Center tested the actual water trapped inside these deep sands, the results were mind-blowing. The water down there is up to 22,000 years old. They checked for tritium, right? That's a radioactive isotope introduced into modern groundwater by atmospheric nuclear tests in the 1960s. Well, they found absolutely zero tritium in the deepest aquifers, meaning the water down there is literal pristine fossil water, safely sealed away since the last glacial maximum. So the crucial point here is that this river was very real, it was very large, and it flowed straight out of the Himalayas. And that completely flips our entire understanding of human history in this region. Think about the Indus Valley Civilization, one of the greatest societies of the ancient Bronze Age. An obvious paradox pops up. Why would they build massive, highly complex cities right in the middle of a harsh, unforgiving desert? Well, the answer is they didn't. When archaeologists mapped out the known Harappan settlements, they realized something absolutely incredible. Over 60% of these ancient settlements weren't actually on the Indus River at all. They were clustered tightly along the banks of this dead Ghaggar-Hakra paleochannel. Look at Rocky Garhi, spreading over 350 hectares. That makes it the largest Indus site ever found. Or Kali Dangan, which features the world's earliest plowed agricultural field. And Ganriwala, a massive, unexcavated regional capital sitting right on the dry Hakra trunk. These were not tiny desert outposts, guys. They were a thriving, bustling riverfront metropolis. And this brilliantly illustrates that the Lost River wasn't just a source of drinking water. It was a navigable Bronze Age superhighway. I mean, archaeologists have literally found marine shells from the coast way far inland at sites like Kalibangan and Banawali. At Banawali, they even found fortified urban walls made of high clay that were specifically engineered to withstand massive river floods. This roaring waterway facilitated a vast, extensive trade network, connecting the agricultural heartlands of ancient India straight out to the Arabian Sea. Section 1. The tectonic death blow. So how exactly do you murder the greatest river of the ancient world? Well, the culprit wasn't just a simple drought. It was the Earth itself. Let's trace the timeline here. Around 22,000 years ago, during the last glacial maximum, the river was at its absolute peak flow. But during the mid-Holocene, a major tectonic shift occurred. The Earth's crust literally warped. This violent seismic activity altered the topography and captured the Saraswati's two main glacial lifelines. The Sutlej River was violently snapped away to the west to join the Indus system, and the Yamuna River was torn away to the east to join the Ganges. It was a tectonic death blow. Starved of its vital Himalayan meltwater, the Great Saraswati was reduced to just a sluggish, seasonal stream dependent entirely on the monsoon. By around 4,700 years ago, the river effectively dried up for good, and the impact on human history was devastating. Without water, the massive urban centers of the Indus Valley Civilization were permanently abandoned during the second millennium BCE. The populations had absolutely no choice but to migrate eastward toward the Gangetic Plains, leaving their great cities behind to be swallowed by the expanding desert. Let's move on and see how this builds up to today. The surface of the river may have died, but underneath, it left a profound legacy. Buried deep beneath the modern Thar Desert is a colossal, 100-meter-thick sand body. And trapped inside that highly porous sand is a massive underground reservoir of sweet, potable fossil water. The ghost of the river is still there. Today, this mapped paleochannel presents an unbelievable developmental opportunity. These ancient subsurface channels actually function as high-capacity, interconnected aquifers. And because the water inside has extremely low salinity, it is perfectly potable. Plus, since these buried sandy channels possess high hydraulic conductivity, they make the ideal natural reservoirs for artificial groundwater recharge. By systematically managing these ancient repositories, we suddenly have a sustainable lifeline that could actually alleviate the severe, chronic water scarcity currently choking the hyper-arid Thar Desert. We started this explainer looking at a myth, right? And we ended up finding a massive geological reality that literally shaped human history. The Saraswati River, the mother of the ancient Indus Valley, was killed by the shifting Earth, only to be resurrected by modern satellite technology. The river that gave life to ancient India might just do it all over again for our sustainable future. It really makes you wonder what else is hiding right beneath our feet. So hit that like button, subscribe, and let me know in the comments, what lost mystery should we uncover next?